A journey to Jupiter. Hello, cosmic enthusiasts. Today, our journey takes us to the majestic realm of Jupiter, the giant of the solar system. But before we launch into the depths of space, let's indulge in a captivating exploration of the cultural tapestry woven around this inspiring planet. Jupiter, with its colossal presence, has certainly cast a profound influence on the creative minds of producers, artists, and dreamers across time. In ancient mythology, it was revered as the king of the gods, a deity of thunder and lightning. Poets penned verses in its honor, and artists sought to capture the grandeur of its stormy bands and iconic Great Red Spot. Zoom into the present, and Jupiter continues to hold sway over our collective imagination. From its mesmerizing cloud patterns to its intricate dance with its myriad moons, this planet stands as a celestial muse in our cultural landscape. Despite its challenging conditions for human habitation, scientific missions have set sail to uncover the secrets hidden within its swirling atmosphere. Looking ahead, the future might hold technological marvels that allow us to venture beyond the clouds, sparking conversations about the potential for human colonization. And this video is all about it. Are you ready? Let's go! Know your destination. Before we embark on this cosmic journey, let's get to know Jupiter a little bit better. It is the mighty gas giant of our solar system. Jupiter, the second brightest planet in the night sky, was first discovered by early astronomers because of its brightness, second only to Venus. In 1610, Galileo Galilei noticed what he initially thought were four small stars accompanying Jupiter. These points of light turned out to be Jupiter's largest moons, now referred to as the Galilean moons: Io, Europa, Ganymede, and Callisto. Jupiter completes one orbit around the Sun in 12 Earth years. Therefore, on your 12th birthday, Jupiter will be in a similar position in the solar system to the one it was on the day you were born. To grasp the enormity of Jupiter, imagine that 11 Earths could be lined up side by side across its surface. It boasts a diameter of 89,000 miles or 143,000 kilometers. Visualize an immense sphere with a turbulent atmosphere, swirling storms, and a magnetic field so powerful that it can cause compass needles to spin. Now, why does this matter, you may ask? Well, imagine being on this planet. The atmospheric pressure is beyond comprehension, crushing everything in its grasp. The air here is no gentle breeze. It's a tempestuous ballet of gases and storms. Stepping into this world without the right gear would be like facing death. And the temperatures? Forget about the cozy warmth of your favorite jacket. Jupiter's atmosphere hosts extreme cold and heat zones, with temperatures plummeting to hundreds of degrees below freezing in some regions and soaring to scorching highs in others. Your everyday gadgets wouldn't stand a chance in this celestial furnace. But fear not, intrepid explorers, for beneath these challenges lies a realm of scientific intrigue. The vast atmosphere and powerful magnetic field of Jupiter offer unique opportunities for study. They shield the planet from harmful solar radiation, providing a potential haven for scientific instruments and future exploration. Astrophysicists, the investigators of the cosmos, along with physicists and engineers, employ advanced tools to decipher the enigmas of Jupiter. A total of 9 spacecraft have embarked on missions involving the outer planets, with all 9 missions entailing encounters with Jupiter, and 4 of them also venturing to Saturn. Among these, Voyager 2 distinguished itself by not only reaching Uranus and Neptune, but also journeying to other planets. The 9 missions encompass Ulysses and New Horizons, whose main goals weren't focused on the outer planets but utilized Jupiter to enhance their orbits around the Sun, Ulysses, and reach Pluto, New Horizons. At the time of the New Horizons launch, Pluto was still considered a planet. Furthermore, Cassini-Huygens utilized a gravity assist from Jupiter while on its mission to explore Saturn. Out of the 9 missions, only 3 of them were dedicated orbiters. Galileo spent 8 years orbiting Jupiter. Cassini orbited Saturn for 13 years, and Juno has been orbiting Jupiter since 2016. As of today, we know so many things about this planet. Here are some surprising ones. First of all, it's similar to a star, but it never got massive enough to start burning. Second, Jupiter is a gas giant and doesn't have a solid surface, but it may have a solid inner core about the size of Earth. Third, Jupiter, just like Saturn, also has rings, but they are too faint to be seen. However, some sophisticated telescopes allow us to spot them. For instance, take a look at this image from the James Webb Space Telescope. In this wide-field view, Webb sees Jupiter with its faint rings, which are 1,000,000 times fainter than the planet, and two tiny moons called Amalthea and Idristia. The fuzzy spots in the lower background are likely galaxies photobombing this Jovian view. As you can understand, there are many things we know about the King of Planets, but the journey of understanding is ongoing. Planned missions such as the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, and NASA's Europa Clipper are charting courses to explore Jupiter's moons, unraveling the complex relationships between these celestial bodies. Similar to Da Vinci's intention to discover the hidden truths about Venus, these missions strive to enhance our understanding of Jupiter, its moons, and the enigmatic aspects of our solar system. Specifically, the JUICE mission will conduct meticulous observations of the immense gas planet and its three substantial moons, Ganymede, Callisto, and Europa, utilizing a collection of remote sensing, geophysical, and in situ instruments. The objective of this mission is to analyze these moons as celestial objects and potential habitats, delve into the intricate environment of Jupiter, and examine the broader Jupiter system as a model for gas giants throughout the cosmos. Reasons to go to Jupiter. Now, you might be scratching your head, wondering why anyone in their right mind would dream of setting up shop on Jupiter, a gas giant seemingly inhospitable to life. Well, believe it or not, some fascinating reasons make this enormous planet a potential frontier for future human exploration. Firstly, Jupiter, with its immense size and powerful magnetic field, holds captivating mysteries that could unlock the secrets of our solar system's formation. So it is important to go there to better understand the universe we live in. It's like peering into the cosmic archives, seeking answers to questions about our planetary family's birth and evolution. But it's not just about it. This planet is a unique laboratory for studying extreme atmospheric conditions. Its tumultuous storms, swirling clouds, and powerful winds offer a dynamic environment that challenges our understanding of planetary atmospheres. Studying its atmospheric dynamics could provide valuable insights into Earth's weather systems and the broader mechanisms governing planetary climates. Jupiter's magnetic field is an extraordinary force of nature that holds a fascinating story. Scientists are studying this immense magnetic shield to gain a deeper understanding of the magnetic phenomena, not only occurring on Jupiter, but also on other planets with magnetic properties, including our own. Much like Earth's magnetosphere, Jupiter's magnetosphere is filled with charged particles that originate from the solar wind. However, Jupiter possesses an additional source of particles that sets it apart from other planets. Io, Jupiter's moon with active volcanoes, contributes a significant amount of charged particles to Jupiter's magnetosphere. These charged particles can follow the planetary magnetic field lines and spiral into the upper atmosphere, encircling the magnetic poles. When these energetic particles, predominantly electrons, collide with atoms and molecules in the atmosphere, they transfer their energy. This energy is then released, often manifesting as visible light. This natural process is responsible for the diverse array of colorful auroras observable on Earth. Interestingly, Jupiter also displays auroras at its north and south poles, as illustrated vividly in images captured by the James Webb Telescope. Energy sources take a unique turn on Jupiter. Unlike Venus, the planet itself is not a candidate for human colonization due to its gaseous nature and lack of a solid surface. However, the exploration of its moons, such as Europa and Ganymede, opens the door to potential habitable environments beyond Earth. These icy moons harbor subsurface oceans, and missions like the Europa Clipper aim to delve into their depths, searching for signs of life. And if you want to know more about its moon system, here's something that you might like. Jupiter boasts a remarkable system of moons consisting of 4 large ones and numerous smaller ones. This configuration creates a miniature solar system within the planet's orbit. According to the International Astronomical Union, it is officially recognized to have 95 moons. Among them, 4 stand out as the largest and most significant: Io, Europa, Ganymede, and Callisto. These 4 celestial bodies were first observed by Galileo Galilei in 1610, utilizing an early version of the telescope. Today, they are referred to as the Galilean satellites and are considered captivating destinations within our solar system. Of the 4, Io is renowned for being the most volcanically active object in our solar system. Ganymede, on the other hand, holds the title of being the largest moon, even surpassing the size of the planet Mercury. Callisto, while possessing only a few small craters, suggests minimal ongoing surface activity. Europa, on the other hand, presents a particularly intriguing characteristic. Beneath its frozen crust, there may exist a liquid water ocean containing the necessary ingredients for life. Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Challenges of the trip. Now that we've set our sights on Jupiter, let's brace ourselves for the audacious journey ahead. First and foremost, we need to pick a spacecraft. Forget your standard shuttles. Heading to Jupiter demands a vessel resilient enough to navigate the vast distances and formidable conditions of this gas giant. Engineers and scientists are in the conceptual stages, envisioning spacecraft that can withstand the intense radiation, powerful magnetic fields, and atmospheric pressures unique to Jupiter. Resources pose a different challenge. The voyage to Jupiter is an extensive expedition that necessitates meticulous planning for every drop of fuel, every breath of air, and every bite of sustenance. Sustainability becomes paramount, requiring the spacecraft to be a self-contained sanctuary for the human crew aboard. Additionally, it is worth noting that the journey to Jupiter is a lengthy one, requiring several years to complete. Notably, the spacecraft that holds the record for the quickest trip to Jupiter is NASA's New Horizons, which accomplished this feat in just 405 days. This remarkable achievement, which occurred during its flyby in 2007, translates to a duration of 1 year, 1 month, and 9 days. For a manned mission to be successful, it is imperative to navigate the vast expanse of space, calculating precise trajectories, and ensure the physical and psychological resilience of the crew throughout this prolonged interstellar adventure. Nevertheless, if we were to ever construct a spacecraft capable of achieving the speed of light, the possibility arises that it could potentially take less than an hour to reach Jupiter. Establishing communication with Earth presents another obstacle due to the immense distance and the powerful magnetic field surrounding Jupiter. The Deep Space Network (DSN) systems already used for other deep space missions would require innovative modifications to cope with the unique conditions near Jupiter. The mission's resilience on communication delays, navigation complexities, and potential technological glitches would become inherent factors. Examining how the Juno mission successfully communicated with Earth could provide valuable insights. This ambitious mission involves navigating through Jupiter's radiation belts in a dynamic polar orbit, posing additional communication challenges for the DSN, as noted by scientists. During the orbital insertion phase, Juno will need to redirect its position away from Earth, resulting in a significant decrease in signal strength. To ensure the capture of Juno's data, all the antennae at Goldstone and Canberra will be combined. Although the obstacles of a manned mission to Jupiter are colossal, the potential scientific rewards are equally astronomical. As we prepare for this grand cosmic endeavor, let us not only recognize the hurdles but also embrace the promise of uncovering the celestial marvels that Jupiter holds. Life on Jupiter. Now let's imagine a successful venture. The intrepid crew has conquered the cosmic challenges and embarked on a journey to establish life on Jupiter. As they set foot on this colossal gas giant, let's imagine what life might be like in this distant celestial realm and how it compares to the comforts of our home on Earth. First and foremost, the landscape is nothing short of otherworldly. Jupiter is a colossal ball of gas with no solid surface to walk upon. Imagine an endless expanse of clouds, vast atmospheric bands, and a turbulent atmosphere stretching as far as the eye can see. It's a mesmerizing alien vista that challenges our conventional notions of a planetary landscape. It being a sea of dense gases, mainly hydrogen and helium, extending deep into its interior, we need advanced technologies to navigate this colossal gas giant. Perhaps we could build floating habitats that can withstand the atmospheric pressures and ever-changing conditions. As for the sky, Earth's familiar blue heavens would be replaced by a display of clouds of different shapes and various atmospheric bands. The thick atmosphere scatters sunlight in different ways, creating a dynamic and ever-shifting canvas of colors that is nothing like what we see on Earth. Forget about our serene sunsets. On Jupiter, it would be a perpetual play of atmospheric hues, an enchanting but unfamiliar sight. And the days? Brace yourself, as a day on Jupiter is a whirlwind compared to Earth. The planet's rapid rotation gives it a day that lasts about 9.9 Earth hours. Short days, fast nights, a stark contrast to our daily rhythms. Living on Jupiter would present a unique set of challenges. Gravity, or lack thereof, would be a significant adjustment. Despite its colossal size, Jupiter's gravity is much stronger than Earth's, around 24.79 meters squared, compared to our familiar 9.81 meters squared. This increased gravity could pose serious health risks, affecting muscle and bone density. Adaptations to counteract the gravitational strain would be imperative for the well-being of the inhabitants. Jupiter is also notorious for its fierce atmospheric storms, including the iconic Great Red Spot, a colossal storm that has raged for centuries. While these storms occur in the upper atmosphere and may not directly impact floating habitats, they add an element of perpetual turbulence to Jupiter's atmosphere. Would you be scared to witness a Jovian storm? Life on Jupiter would be a venture into the extraordinary and the unknown. With floating habitats, adaptations to gravitational challenges, and a constant dance with the turbulent atmosphere, inhabitants would need to redefine their understanding of planetary habitation. It's a life that pushes the boundaries of our imagination. As we conclude our celestial journey, feel free to share your thoughts on this video in the comments below, and stay tuned for our next adventure. We'll see you soon on the channel.